Hello again. Today I want to show you a little anti-disassembly trick that I encountered in a sample of the Pony malware that just messes up the decompilation result that looks a little bit confusing on first glance. And in this video I want to show you how you can fix the decompilation result and also make a little bit of sense what's going on here. I will post the hash here in the description, so you can download this. Got the sample off of Malware Bazaar as per usual, and then you can take a look at it yourself if you want. Let's just open the functions here in the symbol tree and jump to entry. Now, this looks quite strange. So, Gidra tells us here, flow control encountered bad instruction data. There is some unreachable block, and the entry function is just void, and return. So the decompiler gives us nothing. If on the other hand we look at the disassembly listing in the middle, we can see that there's actually more going on. So why is that? So let's start with these 3 lines of assembly here. And here are 3 XORs between EDX and EAX. What this is actually an XOR swap. So this allows you to swap 2 variables without needing a temporary variable. By the way, there's a nice Wikipedia article on this. So this will just switch or swap EDX and EAX. In the next line, we can see a push instruction. So we're going to push something to the stack, and this is going to be what we can see here in this label. So this call to a function, and then this exit process. This is what is happening here, and then comes this no operation. Now get ready for the weird part, because this is the part that's going to follow now. The CLC stands for clear carry. So that means this is going to clear the carry flag in the CPU. This is followed by another NOP. And then we have here this JC, which just says jump if carry is set. So right away we know this jump down to here, to this label, is never going to be taken because carry is cleared, followed by the no operation. So if this label says jump if carry is 1, we're never going to do this jump. Then we get another NOP and then this return, which you can see was decompiled right here. This is the trick. This is what confuses the decompiler, and that is going to be this jump, and this jump actually goes to some garbage data. This data does not make any sense. The decompiler can't do anything with it. It's not valid. So that's what is this node bad instruction right here. It's because of this FE. So how does this work then? We have this return here and this bad instruction, but the malware has to do something, right? The trick is here with this push. So this label, this address, is placed on the stack. This is going to be the address right here. And then when we come down here, the jump is not taken and we get to this return. This return is going to take the value that is on top of the stack and set the EIP, the instruction pointer, to that value. And this is going to be the value right here. So when you execute this, you will eventually end up at this return. And from this return, the malware will continue execution right here. First of all, let's patch this so we can get a nice decompilation result. So we said the return, we don't really need it. So I'm going to go right click here and I'm going to say patch instruction. And now, this takes a moment. I will just replace this return with a NOP. So here, something changes right away. We get this halt bad data. That is because of this FE here. Just do a right click, We're going to say patch instruction. We're going to make an op out of it. And look at that. Now we get the flow of the code as it actually happens. In the decompilation, we just go through this. This function is called. And after this function returns, we get to exit process. And that is exactly what we can see here in the disassembly. Now, of course, this little trick is not only used here in the entry function, but also in this function, as you can clearly see. This has to be cleaned up too, if you want to get a nice decompilation result. But it's exactly the same as I showed you in the entry function. The nice thing is, to get a better understanding of this, we can just load this into a debugger and go through it step by step again, so you get a feeling of the flow of the code with this little trick enabled. Let's jump over to a dynamic analysis and run the malware. Here I am at the entry point, and let's start with these 3 XORs. It's going to swap EAX and EDX, the values that are in here. So let's just step 3 times until we get to this push here. So I'm going to go step into, and then again, and then again. And as you can see, the values of EAX and EDX have been swapped. Now we come to this push right here. That is going to push this function to the stack. So I'm going to do a step into here. And as you can see down here, there is now this value on the stack. And now comes this clear carry. Now the carry flag is here, it's already 0. As we said, this does nothing. And then this jump down to this nonsense value will of course not be taken. We can just skip over that, come to this no operation instruction, and here we are at the return. Where are we going to return to? Well, we're going to return to this address here. So we're just going to set the EIP to the address that was pushed to the stack up here. So let's step in. And as you can see, we are now with the EIP at the address that was on the stack. And the address is of course popped off the stack because of the return. Here, this function is called, and this is exactly the function that we saw in Ghidra. Now that we saw the execution of this code in the dynamic analysis, I think this gives a pretty good idea of what's going on here. Now, in this malware, we have a jump that is never taken. But it can also go the other way if you think about it. For instance, let's say we have an instruction that sets the 0 bit in the CPU. And that is followed by JC, so jump if 0 is set. Then we would have a jump that is always taken. For example, there could be something like this. You have XOR, EAX, and EAX. This here will set the 0 flag in the CPU. And then you have a jump if 0 to some address. Techniques like this are there to confuse the analyst, to make analysis harder, to put some inconveniences in the way of someone analyzing a malware. So with that being said, I'm going to make a cut here. If you came this far, thank you very much for watching. I will see you around. Goodbye.